series. Now we are coming to the next part, that is the bus bar. And here we will focus on the air insulated substation and the AIS bus configurations. Basically, bus bar is a system where all the incoming and outgoing feeders, lines, transformers are connected through different isolators and breakers. Majorly, the selection of any bus bar depends on the amount of flexibility required in operation, the immunity for total shutdown of the system, and the initial cost of the installation, and the maximum load handled by the bus bar. As we know, we have three-phase system in AC transmission, and mostly three conductors are there, and they have the better current carrying capacity, which allows to cater to the different types of feeders, both incoming and outgoing. So here we have five types of system like single bus bar, main and transfer bus bar, double bus bar, breaker and one and half scheme, and ring main system. We'll go individually through each of them. Here, this is the single bus bar system, and the symbols here are shown: the bus isolator, circuit breaker, CT, and line isolator for individual bay, and all the feeders are connected to the bus bar, and here it is only one main bus, and it is used when cost is a major constraint, and the operation is very simple, and protection also. The disadvantage here is poor reliability. If any of the bus bar components goes wrong, then complete system shutdown is required for the repair and maintenance. And to overcome this, we have next setup system where it is called one main and one transfer bus. We have another bay for this scheme, and that is known as the bus coupler, which connects to the main bus and transfer bus. For example, on the left hand side, some sources are there, some loads are there. Similarly, on the right hand side also some sources are there and some loads are there. So section wise bus section will be there, and we can have few incoming and few outgoing sessions on one section, and few other incoming and outgoing in another section. And if we want to take maintenance for any of the bay, breaker, or CT, that can be done by utilizing the bus coupler, which was not able to do in the last simple system. Next comes the two main or double bus system. Here we have set of another set of equipments which can connect to either bus 1 and or bus 2. The arrangement is different, and equipments are more, which allows to have both base shutdown as well as the bus shutdown. In the earlier scenario, when bus shutdown was required, we cannot cater the whole system load. But here, total complete bus shutdown can be taken, and the reliability is high, but the complexity gets more, and the protection also require more attention. Bus bar protection is required. Next comes the breaker and one and half system. Here, with respect to the bus bar and the bus coupler, whatever advantage that we had in the main one transfer as well as two main bus, both of them are combined, and total system can be operated if at all bus shutdown is there or the base shutdown is there. The reliability is much higher in this system. The initial cost of the system is more complex. Next comes the ring main system. Here you can see it forms a ring, and the incoming and outgoing feeders, you can see the arrangement. The operation here also is highly reliable and flexible, but the protection becomes more complex in this circuit. Next comes about the material used. Some bus system use hollow pipes, and these pipes are rigid, and here the clearance remains constant as you see in the picture, and due to the large diameter of the pipes, the corona loss is also substantially less in this kind of rigid bus system. Here is the strain type of bus bars. Here we have OIS are strung between two supporting structures, and strain type of insulators are required. And here we can see sag in the conductor due to loading. And these are suitable for earthquake prone areas. Similarly, we can see depending on the voltage level, which type of bus bar is suitable, comparing the cost as well as the flexibility, that is the reliability. For 132 kV, the one main one transfer can be used with section isolators. Similarly, for 220 kV double bus single breaker, 400 kV breaker and a half scheme, and 765 kV breaker and a half with double bus double breaker system is required, because there the reliability plays a very important role, and cost is not the issue while handling so much of power. Thank you for your patient hearing. In the next, we will be discussing about the major component, that is the power transformer in a substation.